In question 2, we're told when light of a certain frequency is shone on a metal surface, electrons are emitted and they have a range of kinetic energies. In part A, we need to explain in terms of photons why the electrons are released and why the kinetic energy varies up to a maximum level. Well, energy is needed to release the electrons from the metal. Each photon has an energy which is given by the Planck constant multiplied by the frequency of the photon. One photon can be absorbed by one electron, transferring its energy to the electron. The minimum energy needed to free an electron is called the work function and given the symbol phi. If the photon energy is greater than the work function, the electrons will have surplus energy as kinetic energy, and this is given by hf minus phi, the photon energy minus the work function. Electrons on the surface require the least energy to escape, and so these are released with the maximum kinetic energy. Electrons below the surface of the metal will need more energy to escape, and so will be released with less kinetic energy. In B, we're given a graph something like this, and in part 1 we need to mark the threshold frequency, f0. Well, this is the threshold frequency, the lowest frequency at which electrons are ejected. In part 2, we need to draw a line on the graph for a metal with a higher threshold frequency. Well, a higher threshold frequency will be up here, but the gradient will be the same, something like this. And in part 3, we need to state what is represented by the gradient of the graph. The gradient of the graph gives the Planck constant, which we can show here from the photoelectric equation, which matches the format of the equation of the straight line graph y equals mx plus c, where we've plotted the maximum kinetic energy on our y-axis, giving the Planck constant as our gradient, frequency on the x-axis, and the y-intercept is minus the work function phi. In C, the threshold frequency for a particular metal is 5.6 times 10 to the 14 Hz, and we need to calculate the maximum kinetic energy of the emitted electrons if the frequency of the light striking the surface is double this frequency. Well, we need to use the equation hf is equal to phi plus ek max, and at the threshold frequency the kinetic energy is 0, which gives us hf0, the Planck constant multiplied by the threshold frequency, is equal to the work function phi. So we can write that hf is equal to hf0 plus ek max, and then we can rearrange to give the maximum kinetic energy is hf minus hf0, which we can simplify like this, then putting in our values for the Planck constant and twice the threshold frequency minus the threshold frequency gives 3.7 times 10 to the minus 19 joules.